about the equation. What matters is how you get to using the equation, okay? Your problem will be, you never know when to use it. Okay, so we wanted to do something for the shelf life, yes? Shelf life? So,
I think we already got to it, though.
Yeah,
what happened?
I don't think we ever got to it.
We never got, I know we didn't get to it. Let's say, let me see something that makes sense, because I don't have numbers. Okay, whatever. Okay, so let's say calculate the shelf life. Shelf life is the amount of time it takes for your substance to decrease 5% in concentration. Okay, that's what shelf life is. So when they make the pill, what is the amount of medication inside the pill when they make it?
95 to 100%.
That's 100%, yes? That's 100%. And over a period of time, what happens to that compound? Starts decomposing, yes? It decomposes, just like you will decompose one day. Oh, nice for you to join us, my friend. So, when it decomposes 5%, what's the concentration then? 95, yes? And that's called shelf life, whatever amount of time that takes. Even if these numbers that I'm doing here don't make sense, it's fine. So calculate the shelf life for a medication. Is the rate constant?
The second inverse, yeah.
Okay? So what do we do first?
Can we?
First, we need to know the order, yes? We don't know the order, we can do the problem.
Yep.
What is the order here?
First order.
The order is first order. It is first order because
Second inverse.
the units on the rate constant is inverse time. So this is first order. Okay? Now, what do we use to solve this problem? Integrated rate law, or Half-Life?
Integrated.
Integrated rate law.
Could we
Okay.
say that the initial concentration would be 100%?
You could, you gotta put some numbers in.
Yeah.
So,
So it's going to decrease in con.
now this looks like it doesn't have enough information, does it? Doesn't it not look like it doesn't have enough information? It looks like it doesn't have enough. Okay, but I don't know, I don't wanna deal with that yet. let's deal with the equation. The equation for first order is
ln of AT
related to the ln, yes?
Yep.
It is the first one, so it has a minus kt
plus.
plus the ln of A0.
Yep.
Simple equation, yes?
Yep.
Not that hard to memorize that equation. Not the way I have explained it to you anyway. So, now I need this number here, k. Do I have that k?
Yep.
Yes. What is this?
Time.
This is time, right?
Mhm.
The time it takes. And shelf life is time, yes? So I am looking for this number. I have this number. Where are this number and that number? Where are they? They are contained in what it's asking you for. Shelf life, by definition, means that you began with 100 and you finished with 95.
Okay.
So, you can put here 100 and you can put here 95. Or you can put here 1.0 and here 0.95. Okay? You can say this is molarity, you can say this is grams, you can say this is milligrams. It does not matter. Yes? Because no matter what you put here, at the end is going to be the same ratio, the same difference. Okay? So, because it doesn't make sense to have 100 grams, yes? It does make sense to have 100 milligrams, right?
Mhm.
So, we're going to use these numbers, okay? We're going to use 1 and 0.95. So, here's what we're going to do. We're going to solve for these things, yes?
Mhm.
So, ln of AT minus ln of A0. Is that good, yes or no? Yes? Divided by minus kt, yes? Minus k here. Minus k on this side. Now, because I just put a whatever rate constant there, maybe this number that we're gonna get is not gonna be a good number, okay? But it doesn't matter, all we care about is going through the motions, yes? How much is this?
How come we assume like 0.95 and not something else? Like, it's like if only one time passed, basically. Because you said it decreases by 5% every time, right? Okay.
You gotta use 95% of it.
Okay.
If you would have started with 325 milligrams, you need 95% of that, which is, you gotta multiply 325 by 0.995.
Okay.
What is it? Did you watch those videos and catch up, man? My class you missed? Did you hear what I said? Did you watch them videos and catch up?
5.6 times 10 to the negative 9.
5.6?
Times 10 to the negative
10 to the negative 9 what?
9.
Didn't do it?
Seconds.
Is that what you get? No?
Wait, you're constant.
What do you mean to say? Do you mean to say he doesn't know how to use a calculator? Is that what you mean to say?
I got it. I didn't see what I did. I didn't put that.
No, it's all right, man. Now everybody knows, okay? Don't worry. So what's the number, my friends? I don't care what.
1.7.
Yeah, it seems like
1.7?
1.7 times 10 to the negative 5.
Are you guys afraid? You have to wait until he says it, huh? To catch his mistake? 1.7 times 10 to the what?
Negative 5
What?
seconds.
Seconds.
Okay. That's silly, okay? It doesn't matter. I was supposed to give you a bigger number. I just didn't want to give you another unit. You gotta convert and whatever.
Turn around and say.
Okay? Yes or no?
done.
Yeah.
Yeah, that medication has no shelf life, yes?
Yeah,
Alright.
it's like an instant and it's gone.
No shelf life. Most of the time, shelf life is in years, yes? 1 year, 2 years, 3 years. Okay, let's do another one, yes? This will be the end.
What about if you give us like initial amount?
Huh?
Like if you gave us like an initial amount
About what? Initial amount of what?
of like a substance any.
I gave you like the initial amount for this question?
No. Let's see what you're gonna do.
I mean, if you just multiply by 0.95, that's the case.
No, that's okay, that's a good question, okay? Let's say that I say that I am calculating the shelf life for a medication that is 325 milligram pill, yes?
Mhm.
Okay? I gotta use 325 milligrams, yes or no? I gotta use this number. I mean, I don't have to, right? Because shelf life by definition is something, but let's say it's 325 milligrams, then this is the initial, and then what's 95% of that?
That times
Multiply it. 325 times what gives you 95%? 0.95, yes? We learned this, and what type of math was that?
A long
Baby
time
math?
ago.
Right.
Yeah.
Must have been in the 3rd grade or 4th grade. So if you multiply this times 0.95, it'll give you 95%. How much is it?
300.
What?
308.75.
No, guys, too many numbers, yes? I can only keep 2 or 3 in my head at the same time. 308 milligrams, yes?
Mhm.
That's what it is. So the shelf life, if you were taking a pill that it was 325 milligrams, for example, I have some pills in my office, they're vitamin C pills. They have been there probably 15 years, okay? Not in this office 15 years, but with me, 15 years. And they're brown already, okay? So I challenge you to go eat one with me. Okay? They taste good. Okay? So, if the pill was 500 milligrams after all these years, then what has happened? It's not 500 milligrams anymore vitamin C, yes?
Mhm.
It is 100 milligrams. You can still take it, right? Unless the other byproduct or the decomposition kills you, then it's not good. For antibiotics, for example, past the expiration time, you should not take them, yes? But if it's not an antibiotic, it's a vitamin, you can take it, you're just taking less of what it says. Okay, but don't take them anyway. I don't want any of you to throw a fit and then say, oh, it was your fault. Okay, how long does it take for the concentration to drop? And this is important for some of us ingesting illegal substances, yes? Okay? Because we want to know how long it takes, right? Before it's out of our blood. So how long does it take for the concentration to drop below police detection limits, yes? To drop from, we need to find out what the detection limit is.
For what substance?
Well, that's a substance of your choice. I only give you the tools, you gotta walk. So from 0 point that to this,
So that would be second order.
I don't know.
Because you usually have,
Is it the negative 25th? 21st?
yeah.
It's a very small number.
Yeah. Both things exist in this world, small things and big things. That happens to be a small one. Okay. So, first things first, yes, what order is this? Second order. How do you know it's second order?
Because of the unit.
The units. These units are a little confusing, yes? Moles per liter is the same thing as M where? This is molarity, yes? This is M on the bottom, this is seconds on the bottom, so this looks like this. M to the minus 1, second to the minus 1, yes or no?
Yep.
Okay, good, this is second order. It is second order, so what is the equation for this?
1 over ln of AT.
No. Not 1 over ln. ln is only first order.
1 over AT.
Yeah, 1 over 18, okay? Believe me, some of you will make this mistake, we'll confuse them. Positive KT or negative KT?
Positive.
Positive KT. Positive here or negative here? Positive. It's always positive here, yes? 1 divided by A0. Okay? And now I just plug in the numbers, yes? This is very easy. In fact, I feel bad giving you this question on the test of how easy this is. So 1 divided by AT, what's AT?
95?
What?
You gave us the initial concentration.
Yeah, sure, I gave it to you, but what's the number?
0.01 moles.
0.01? Okay, look here. Guys, is this a bigger number or is that a little number? Compared to this one? Bigger or smaller?
Bigger.
It's bigger. So you must have started with this, yes? And then you went to this. So this number must be
The initial
the
concentration.
initial number, and this must be the final number. This is at time t. So that's this number. This is a final number. Yes? So the smaller number is the one that goes here. Because these are reactants, yes? So their concentration is decreasing over time. And I'm going to subtract this on the other side, right? 1 divided by A0, what's A0? That's the initial concentration, is the bigger number. 0, yes? 0, 1, 0, 0. And the whole thing is divided by K. What's K? Okay, very good. And what are we going to say here? We're going to say molarity to the minus 1, seconds to the minus 1. Okay.
Molarity times. No. It's gonna be a
You
very
check
big
the
number.
units, okay?
It's gonna be a very big number.
What did you get?
4.6 cents to the 21st.
Yeah.
A lot of seconds.
Okay, so, what are the units here and here? Huh?
Molarity.
These units are molarity. These units are molarity. So on the top, I have what on the top?
11.11.
No, what units do I have on the top? Yeah, 11.11, but what units? Molarity, does it cancel out with this?
Yes.
It does?
Yeah, because it's 1 over a million.
So, molarity cancels with that? That cancels?
No. But that's not what you have.
But you
Well, you
have
told me
1
molarity on the top,
over
yes?
molarity.
No, but not that.
This is not molarity on the top, this is molarity on
Bottom.
the bottom. This is molarity on the bottom. And this is molarity to the minus 1, also on the bottom. But this means this is on the top, yes? And this was on the bottom. So they do cancel each other out. So we're gonna say that cancels with that, because this is molarity to the minus 1, yes? Okay? So molarity cancels out, and inverse seconds goes to the top as seconds. What did you say it was, 4.6?
Times 10 to the 21st.
Times 10 to the 21st, what?
Seconds.
Seconds. You can change that to, you can change it to days, you can change it to years, okay? Yes or no?
Yep.
Okay, that's not so bad, okay? I am going to give you all 3 equations on the test. Okay? All 3. Now, do you need to practice this 20 times? Do you need to do another 50 problems on this? Please. It's a waste of your life, okay? you think about what you are doing and you don't have to do too many of them.
How would it be worded differently to be confusing? I'm sure it's gonna be not as straightforward as this wording. No way.
No, remember, it could be very confusing if it says, oh, the rate constant for the decomposition of this nuclei, blah, blah, blah. Okay, throwing big words at you, does it matter? What are you looking for? You're looking for concentration, you're looking for K, and you're looking for time, and that's it. You don't need to speak English, it could be in Chinese. Okay? I'm serious, it could be in Chinese. You know that I have followed a procedure for doing experiments in the lab. I was in German. Okay, I follow one in German, I follow one in Japanese too. Okay? Because sometimes we got no choice, yes? And I followed it, so you can follow it too. So I'm not German. I look like a German guy, but I'm not. All right, let's do another one, okay? Let's say we have this. This is for the decomposition of hydrogen peroxide. What is hydrogen peroxide used for?
Cleaning wounds,
What is the use of hydrogen peroxide, my friends?
disinfectant.
Disinfectant. For guys, right? I mean, girls don't even know that's used for disinfectant. Girls use it for their hair. Yes? No? You don't know? The girls use it for their hair, believe me. But anyway, they use it for disinfectant, so when you get a cut, what do? You put hydrogen peroxide on it, yes?
Yep.
Of course. And what do you think the hydrogen peroxide is doing? Is what?
Attacking the bacteria.
That's what the purpose of disinfectant means, right? You kill the bacteria, right? So you think it's killing the bacteria. How do you know it's killing the bacteria? Because it foams up white, yes? A little foam. And you think that white stuff is the bacteria dying?
No. It's like the reaction with the bacteria.
The reaction with the bacteria. But do you have bacteria here on the skin here? Do you have bacteria on your skin?
Yeah.
Okay, I don't say on my skin. You know I have some on my skin. But do you have some on yours? You have some.
Yeah.
And when you put the hydrogen peroxide on your skin, does it bubble? Hello?
No.
Excuse me? What do you mean you never tried it? It spills outside of your wound, yes, and you don't see it bubbling everywhere.
Why would I pour peroxide just on my skin?
No, but when you have a cut, the cut is not this big, yes? So the cut is little, and when you put hydrogen peroxide, some of it is outside of the wound, yes? It does not bubble, my friends. The bubbling does not come from the hydrogen peroxide reacting with the bacteria. It does not come from that. Okay? You know where the bubbling comes from? Inside of your cells. Do you know that you have something called peroxisomes for the biology majors here? You've heard of peroxisomes? What do you think peroxisomes have inside? Little vesicles, yes? They're floating around. Little vesicles floating around inside of your cells. And they are called peroxisomes. What do you think they have inside?
Instance of decomposed peroxide.
They have peroxide, yes? They have peroxide. And what is the purpose of the peroxide? Seek and destroy. Okay, the peroxide will kill everything, yes? But you have something that will kill your cells inside of your cells, do you not? If that ruptures inside of your cell, what's going to happen to your cell? It is going to die. So your cell is smart, so it makes an enzyme to decompose it. Okay? It makes an enzyme to make this. There is an enzyme inside of your body that makes this, and the name of the enzyme is catalase. Okay?
Cool.
So it will convert the peroxides into water and oxygen. So when you get a cut, what happens to the inside of your cells? They spill all over the place, yes? Hello? And what comes outside? Catalase. And when this enzyme, you put hydrogen peroxide on the enzyme, what happens? The enzyme starts producing oxygen, and that is the bubbles you see.
Oh, okay.
Okay? So is it from killing the bacteria? Absolutely not. So when you thought, oh, I'm putting all this hydrogen peroxide, it's not bubbling anymore, yay, I killed all the bacteria. You were wrong, okay? What you did is you killed the enzymes, now the enzymes are not doing this anymore, okay? Anyway, the truth is, this will kill the bacteria, and this will kill the bacteria too, okay? So, did you know oxygen will kill the bacteria? If you have an infection, you know what the last thing they're gonna try at the hospital is? When antibiotics don't work, they put you in a hyperbaric chamber, pure oxygen environment. The oxygen will kill the bacteria, will kill you too. Did you know? Did you know that pure oxygen will kill you?
Yeah. Why?
I don't know, you gotta ask it. The oxygen is very oxidizing, yes? Okay. Anyway. Yeah, oxygen will kill you. That tells you everything in large amounts or in excess is bad for you, okay? That's why most smoking weed once a day is okay, but twice is not. Okay? For pain, yes?
I don't know about that, you can't die from smoking weed.
You cannot die from smoking weed, right?
You have to ingest a third of your body weight in 30 minutes.
What?
You have to ingest a third of your body weight in 30 minutes.
Oh, okay.
Possible.
Yeah, that's what Max said. Okay, guys. It will kill you, okay, because the burning of whatever stuff you are taking inside is still killing
If
you.
not, it'll kill you with cancer.
It will kill you. But that's all right, because I could get killed by a car too, so. Do as you wish, okay, be happy about it. So, here's this reaction, the rate constant. Actually, don't do drugs because you're spending money. Yes? You can use that money on your girlfriend, right? Right? That's what girls want. Alright, so we're gonna say, calculate the half-life for this reaction.
Some combination of unique rate and
No, there's an equation for this. There's an equation for this.
yeah, unique rate. That's equal to
No. Yes, this one right here.
that's half. Oh yeah, okay, half life. That's first order. That's a 0.693, right? I'll never forget.
So
that.
what's the deal?
Yeah, that's the.
What equation is it? Is it integrated rate law?
No.
It could be, right? Because the half-life, guess where the equation for half-life comes from?
Probably.
Integrated rate law. But it is a simplified equation, so you don't have to plug in all the numbers all the time. And what numbers did you plug in to get the half-life numbers? So let's say, and this is for the nerds, yes? For the nerds. It's not for normal people, okay? It's only for nerds. So you only listen if you are a nerd. If you're not, if you're a stud, then don't listen to it. Half-life means what?
Time it takes for half of the substance to decompose.
Yeah, for the substance to decrease in concentration by half. So how much did you start with? Give me a number. You want 100? Okay. And 50, right? Or you can start with, like we said before, you can start with a 1. And if I started with a 1, that would be a 0.5. Okay? Or you can say, I started with a 1, this is a 1/2. Okay? That's where these numbers come from. Okay? So when we do the half-life, we already did this, and we solve for time. And we say that this is time 1/2, indicating half-life. Not that you do anything with this. Yes? And what order is this? This is first order. First order is the unforgettable half-life, yes? What is it?
Our favorite number.
0.693 divided by 3.
How do you know?
You get 990.
Okay. 0.693
Yeah.
divided by
Okay.
K. It is always divided by K, yes?
Well, it's specific, so.
It's always divided by K. So, how simple is this?
I'm not gonna put it in scientific notation.
0.693 divided by the number I've given you.
We calculated this into that for you?
My calculator sucks.
Okay? What is it? What's this number?
9.9 times 10 to the second.
9.9?
I mean, 990.
990 what?
Seconds.
990 seconds. Okay?
So the equation doesn't really serve a
I
purpose.
mean, you could use the
Which
first
equation
one.
doesn't serve a purpose?
Like the chemical equation.
No, the equation does not serve a purpose, no. The equation is there for what? Do you think the equation is there to confuse you? The equation is there because you're talking about the decomposition of this thing and they give you the half-life, I mean the rate constant for it. I could make it abstract and say for this reaction theoretical, or I can give you a real one. I think some of you guys like it real better. Guys, let me ask you something. This is, what order is this? First order. Give me second order without looking in your notes. What's second order?
Yeah.
Outstanding. 1 over K, yes? That's it.
No.
No.
You have to times it by.
This good?
Yeah.
All right, very good. You had time to look in your notes. Good job. You are fast. I gotta be careful with you cheating on my test. So, and what's zeroth order?
Something
A
like
is 0 divided by 2K.
A0 goes on the top, yes?
Yes.
Okay, 2K. All right, whatever. Which of those is a constant number?
Okay.
No, it's not.
Which of those equations is a constant half-life?
first one.
Okay, is this number changing over time?
No.
The rate constant? No. Is that number changing over time? No. So this half-life is a constant number, meaning that it only has one half-life. Okay? Now this half-life here depends on what? On the initial concentration. Does this half-life change?
Yeah.
Yeah, this half-life changes. Because at one point this number will be one number, at another point this will be another number. So this number is not constant and this number is not constant. Only the first order half-life is constant. So when you look at the medications, okay, when you look at whatever you're going to look at, if it's not first order, would you see more than one half-life? Do you know that there is a program called Micromedics? Micromedics, write it down. I don't think, is it free? It used to be free. Never read, write it down, man. You already did it? Oh, okay, good job, man. Micromedics, and what that tells you is, it gives you like what a pharmacist would get. It gives you what order the reaction is. It gives you the half-life. It gives you the rate constant. It tells you how the medicine works inside of your body. It tells you where you get rid of it, through the kidneys or whatever process, by what.
Okay.
And then it gives you the amount that people take, sometimes by body weight. Okay, sometimes body weight is not important. Okay, so you can go in there and calculate, let's say you're doing antibiotics, or you can search it on Google, yes, it'll tell you the same thing. You can go in there and search for the amount that you are taking and recalculate what your doctor does, right? Anyway, I used to have that app on my phone, but it started having problems. Okay, you want another one, yes?
Yeah.
You want another one? I'm getting tired of this. CH4. Guys, you want to test next week?
Sure. On
this chapter only?
On this chapter only, no. So it's not gonna be next week, okay, I take that back. Alright. So,
If it was just this one, I'd say.
I was just trying to stress you, you know.
I see it right now.
The half-life is
Calm down.
56.3 minutes, right? Calculate the rate constant.
Ooh. It's a nice little twist.
I want the rate constant in seconds, okay? Units of seconds.
Okay.
Whatever, I can't tell you more, but in seconds, not in minutes.
Are the minutes inverse?
What happened?
Is it inverse minutes or is it?
I can't hear you.
Is it inverse minutes or is it just minutes?
Just minutes.
Okay.
Okay, how do you know which formulas
We could change the half-life to seconds. You can change, calculate the amount of seconds in the half-life. And I think it's first order. Because he's only dealing in seconds.
How do you know if it's first, second, or
Okay. What the deal is?
How do you know if it's first, second, or zero order?
What he gave you? I don't know, what do you think?
I think it's first.
I guess
That's
it's first
intuition.
order. It doesn't say it anywhere, yes? I will probably, if it's not very clear, like it's not here, I will probably tell you what order it is, okay? Because can you guess the order from here? Can't guess the order from here because this is half-life. But I have given you only one number, yes? And I have not given you initial concentration. It would have been a problem if I gave you initial concentration for this. Because if I give you initial concentration, do you use it for first order? No. But do you use it for second order? Yes. So more than likely on the test what's gonna happen is, I don't want you to guess, I will tell you this is first order. So you write it down. Your purpose was to notice that I didn't know what it was, yes? So if it is first order, what half-life am I going to use?
No, it's first.
The famous half-life, yes?
Yep.
Famous half-life. And now what am I looking for?
You're looking for the
K.
constant.
Silly problem, yes? All problems in this class are silly like this. Because this is an easy class in which everybody gets an A, yes? Divided by T1 half. You agree? So I am going to say 0.693 divided by T1 half, what's the half-life? 56.3 minutes. I need this in seconds. And we all agreed last time that there are 60 minutes in 1 second, yes? We agreed on that. You guys all chanted that answer. Okay, so 1 minute? 60 seconds? Is that good? All right. So the minutes cancel with the minutes, and the answer is 205 times 10 to the minus 4
Yep.
inverse seconds. Okay? 2.1?
I got 2.05.
Okay. Whatever it is.
I'm not gonna debate about it.
Okay, last problem before we start talking about biology.
Really? That's kind of surprising.
Yeah. That's what you guys wanna learn, yes?
We're gonna learn biology the chemistry way.
No, there is only one way, yes? Okay, let's say A gives you B, and this is R. It's like this.
Okay. That's right. Oh, second order. That's CA.
Yeah, CA means calculate. The half-life. If the initial concentration was 0.0539 molarity, and the rate constant 1.3 times 10 to the minus 2. What wording can confuse you here? How can I make this difficult to understand on the test? I start writing a whole bunch of things, right? Anyway, what do you need here?
Make a story around
Initial concentration, yes, I can make a story.
it. Yeah.
And you will probably be confused by the second sentence, yes? You'll be like, oh my God, what did he say in the first sentence? What is important is, here's a concentration, yes?
Mm-hmm.
And that happens to be initial concentration. What do I have here? Rate constant.
For second order.
Initial concentration, rate constant, and what am I asking for? Half-life. Doesn't matter what it says in the rest of the problem, it doesn't matter if it's a paragraph or two. Okay? What order is this reaction? Second order. You know it's second order because of
Unit.
the units, and you also know this is
And
second order because of
The
the
rate.
rate law.
Yeah.
This is called rate law. So this is second order, so T1/2 is equal to, what is it equal to?
1 over.
ln
over.
One
One over
K.
2, yes?
No.
Like this? No? Why not?
There's a K in there.
Because that's not what it is, yes? Okay?
Yes.
Alright, very good. Half-life is 1 divided by K, is always K on the bottom. Here is A0 is on the bottom because it's on the bottom for second order. So, do you mean to say I just plug in the numbers?
Yeah.
This class is not challenging. Okay? It is not. So, we're gonna make it challenging, don't worry. I'm gonna give you a question on the test, very challenging, that I've never done. So you get it wrong, and that will be challenging for you. Right? That's what a challenge is, you can't do it. What's this equal to?
1.416 times 10 to the 3.
Does this molarity cancel out with this molarity?
Yes.
Yes.
It does, yes? What did you say it was?
1.416 times 10 to the 3.
1.4,
1.6.
1.6, let's just leave it at 1.4 times 10 to the what?
30.
To the negative third?
30.
To the third what? Okay.
Alright, Mr.
Did he
Brown.
get this quote? Did he do it right?
Yeah.
They're wrong.
No, but girls are waiting for you to get stuff wrong so they can tell you. That's what happens all the time. They can't wait. All right, guys. I think we beat that one to death, okay? Now, on the test, it might not be exactly the same problems, yes? But at the end of the day, what are they going to be like? They're going to be either you find the concentration, or you find the time, or you find the rate constant. That's all there is. Okay? Let's talk about something called the collision model. Do you guys have the slides? My secretary has not sent them to you.
No,
I'm telling you.
you ought to fire her.
And I'm gonna replace her with two Victoria's Secret models. Okay? They'll do the same job, yes? This secretary never does anything right.
You'll get more office visits. That's okay.
Yeah, yeah, that's what I want. Okay, collision model. I'm gonna send them to you, okay? But remind me. But not in an email, because you know I have 1,600 unread emails. Collision model says. The collision model says. What is a collision?
Collide any time.
Now you can't tell me that a collision is when two things collide. That's like saying the same word, yes? Collision means. Okay, whatever, you get it, yes?
Yeah.
Two things go like this. Okay, collision model says. Look how interesting this is. Collision model says, in order to react, molecules must
Collide.
collide. That's kind of silly, isn't it?
Yep.
I'm not gonna lie to you, that's silly. That's like saying, in order for you to have a crash, you gotta crash. Okay, but what is interesting is, yes, they must collide. If they don't collide, the reaction will never take place, yes? In order to react, the molecules must collide. The collision has requirements, and this is what's important from here. Collision has to have the correct orientation
Yeah, that's discrimination.
Okay? So, like rear-ended, the correct orientation would be? Okay, alright. The collision also needs to have a minimum amount of energy called energy of activation. EA. Energy of activation or activation energy, it does not matter. Now, does it say there, these reactions are the reactions ran by chemists in the lab only? What does it say? This is all reactions known to man, yes? All of them. All reactions known to man need to have what? The correct orientation
And a minimum.
and a minimum amount of energy called energy of activation. Very good. You got it. Is it time to go already?
Oh.
Yeah.
I'm tired. It's a sleepy day today. Right? I'm so tired. I woke up tired. After sleeping 8 hours, I wake up tired.
She didn't catch that.
I should use a little bit of testosterone, yes?
Sure, why not?
Because at the age of 30, testosterone starts dropping.
Oh, does it?
And mine started dropping a while back. Okay, so here's the orientation factor, okay? Maybe I should show you a picture. You want a picture?
Yeah.
Or maybe I just draw the picture.
I like
Show us
Drawing
your
is not
art.
as good as if I show it, yes? Let's see. You like that picture?
Sure, why not?
Did you say this was a woman? No. And let's say
Oh man.
it's gonna collide with, let's say, it's very abstract, yes? And so we have this. These are bonds, yes? Those are molecules, yes? They are, this little atom here is bonded to this atom, which is called atom B, yes? And this is another atom C. Now the product that you are supposed to get, let's say, the product is, that's the product. So during this collision, as this molecule approaches this molecule, C and C collide with each other, yes?
Okay.
So you get this product. And as this C approaches this Z and they collide with each other, do you get product CC?
No.
No. Because the collision needs to be the correct orientation. C needs to collide with C. Because if C collides with Z, it's not going to take place. That is in the incorrect orientation. Clear, yes or no? Now tell me, before I make this CC, what needs to happen? Or at the time of making CC, what needs to happen? This is a bond between what two elements? Element C and element C. There needs to be a bond between these two. What needs to happen during the process?
You need energy.
The energy of the bond is created, well, not created, but transferred into the bond.
Okay, all right. What else?
You need to break the bond between the other two.
Yeah. I mean, if C makes a bond with C, yes, I understand. This is gonna make a bond, whatever's gonna happen between them, love at the first sight, whatever it is, this is. But what needs to happen is, this B and this C must do what? They must break. So this has to break here, yes? And this has to break too. Okay? So bonds need to break, yes.
Isn't this Hess's law? I mean, what is the difference in this? Is
No.
it- No, it's not like related to anything.
Oh, you mean the calculation for this stuff of the breaking the bonds and making the bonds?
And all of that, so isn't this?
It's not called Hess's law, but it's related to the energy needed, yes.
Okay.
But it's not Hess's law, this has nothing to do with Hess's law, this
You're
is
talking
energy of
about, like, the
activation.
energy to clean.
Okay, so, this bond here needs to break, yes? Have all bonds been formed? Are there all bonds formed or no? Is everything bonded to something else somehow, yes or no?
Yeah.
Or do you think there's some elements waiting for a bond to form? All bonds have already been made, okay? I'm gonna tell you right now. The only thing that you can do is what? Break the old ones and form new ones, yes?
Mm-hmm.
So, you need to break this one. Does breaking a bond require or release energy? Requires energy. How do you know it requires energy?
Because
You need energy in order to fix and
You need energy in order to break it. No, that, of course. But why? But why?
because there's a force putting them together.
It's kind of.
It's kind of obvious.
Kind of like common sense.
No, it's common sense to some people, not common sense to me. Okay?
There's
Because
an intermolecular force holding them together that you have
You
to
just have to, yeah, use
match.
energy.
that's right. You have to separate forces of attraction between them. Yes. Forces of attraction of electrostatic in nature. Yes. Forces of attraction of this atom is attracted to this one because of bonding forces, so they could be intermolecular forces. That's not intermolecular forces. Those are bonding forces.
Okay.
Okay? So, energy of activation says that you have to have a minimum amount of energy for the reaction to take place. This minimum amount of energy is the energy required to break the bonds before new ones can be made. Write that down. Hopefully you were not daydreaming when you were looking at me. Navarrete, what did you write down, man?
This energy is required to break the bond, right?
I don't know. So energy of activation is
It's like
the energy
breathing bonds.
required to break bonds before you can make new bonds. So do all reactions have this energy of activation? Yes, of course. And is this energy of activation a positive number or a negative number?
Negative.
It is a positive number. It is always a positive number because it's a requirement, yes? This process is endothermic. So energy of activation is always a positive number. Energy of activation is the energy required to, well, where does the energy of activation come from? The energy required to break bonds before you can form new ones, yes? Now, when in biology you hear that breaking ATP releases energy, what do you say about that? Isn't that what you hear all the time? Breaking ATP releases energy. Do you have a problem with that? I have a serious problem. Because whatever you break is going to require energy, yes or no? Period. It doesn't matter what it is. So here's how it is. We have reactants on this side, reactants on this side, products on that side. This is energy here. And let's say kilojoules per mole. And this is called reaction coordinate, meaning reactants on the left, what on the right? Products on the right. The reaction looks like this. Here's the stability of the products, of the reactants, yes? And then in order for this reaction to proceed, you need to input some energy.
Okay.
Okay? These are called, and remember, this is not going to be written for you on the test. You need to make sure you understand this. These are reactants, these are products.
What do you mean by reaction coordinate?
Reactants and products.
How much energy? Like the time elapsed in the reaction or not?
No, it's a coordinate. Reaction
So the
coordinate.
spike happens when you break the bond.
Huh?
Does the spike happen like that? It seems like the spike.
Yes, when you break the bonds.
So basically, the product is a lesser amount of energy.
Yes.
That's kind of weird.
No, I'm going to explain it, okay? So, here is stability of reactants. Here is stability of the product. Here is an increase in energy. This top of this hill here,
requires less energy.
this top of the hill
Yeah.
is called transition state. In biology, you might read this like this. TS, that. You ever seen that before? No? Well, when you took biology, you probably didn't pay attention. Okay? Transition state. And the chemical at the transition state. So you understand transition state is a place, yes?
Okay.
It is a place. The chemical at the transition state is called activated complex. Okay? The chemical is called activated complex, and the chemical exists at the transition state. How do you like that? You like that? Now, the difference in energy between the transition state and reactants is called energy of activation. So, the difference in energy between here and here is called energy of activation. So energy of activation in a way is transition state minus reactants. That number is always what type of number? Positive or negative? It is always positive. Because it is the energy required to do what? Break bonds before you can form new ones. Now, what is this thing from here to here? What is this thing from here to here? This thing from here to here is something you had in 1045. It is products minus reactants. What's that called? This is, we can call it change in energy. It is products minus reactants. Now, in this case, is this number going to be positive or negative?
It's
Negative energy. Negative.
Would you prefer if we write numbers on this thing?
Doesn't really matter.
Doesn't it really make a difference?
It's going to be
I think so.
Okay, let's say this is 5, 10, 15,
It's a release
20.
of energy.
25, 30. Is it going to be a positive number or a negative number? Product is 10, yes? Minus the reactants. The reactants is 15, so this is minus 5 kilojoules per mole.
But doesn't that depend on whether the reaction is exothermic or endothermic?
This is the reason why it's endothermic or exothermic.
Okay.
So, this change in energy is what number?
Negative.
Negative. This means this is exothermic. Now, exothermic is referring to delta H, and delta H is related to heat, yes? There's another word, and the other word is exergonic, and exergonic is for delta G. And delta G is Gibbs free energy, which is total energy. Okay? Now it just happens that most of the energy coming from these things are related to heat, so a lot of times chemists will say this is exothermic or endothermic, but it's delta G. It's overall energy, okay? What's the energy of activation for this? Transition state is
Yeah.
30
So it's 15.
minus 15. This is 15 kilojoules per mole. This is a positive number. This is an energy required. Yes or no?
Yep.
Now, the energy of activation, this number comes from where? Where does the energy of activation come from?
The difference of the transition state and the reaction.
No, where does it come from, this number? Don't tell me from the graph.
Oh,
Energy of activation comes from
The outside is.
the need to break bonds before
forming new.
before you form new bonds, yes?
Mhm.
What if it's spontaneous versus non-spontaneous reaction?
That has nothing to do with this.
Lower,
Has nothing to do with this at all. Spontaneous lower what?
like lower energy would always be a lower energy of activation.
Yeah, but it still has nothing to do with the graph. The graph still looks the same. But yes, things that have a lower energy of activation occur faster.
You said this was referencing ATP energy?
ATP, no, we're not done with ATP. Guys, this number here exists because a need to break bonds before you form new ones, yes? Now, this number here depends on the bonds being broken, yes or no? Right?
Okay.
And for a specific reaction, do the strength of the bond or the attraction between those nuclei, does it change with temperature? Hello? Does the force of attraction between you and your boyfriend change with temperature? It change with temperature?
If it's hot and.
If it's hotter, you don't like your boyfriend? What do you mean?
Depends.
Here, it's so sweaty.
I guess you're right.
man.
If it's cold, then you just want to get together, but then you don't like your boyfriend. You just use him as a coat, yes?
Why wouldn't it change? Because
Huh?
why?
I will smack you silly, boy. Why wouldn't it change?
Yeah.
Does the force of attraction between you and your girlfriend change with
No,
temperature?
not that. Just saying.
You don't have a girlfriend? What's that deal?
Oh, man.
No, I mean, look, let's say, okay, we're drawing it, okay?
That's a nice drawing.
The force of attraction between this nuclei and this nuclei depends on what? What does it depend on?
Size of the atoms.
It depends on the size of the atom, it depends on maybe electronegativity. It's a number, yes? Can you Google this? Google that. Put bond strength for H2. Do it.
I have to go here.
Where's your cell phone? You don't have a tactile cell phone? Smartphone? You don't have a cell phone?
No, I don't know.
Oh, you don't have signal. Oh, we don't have signal, yes? Okay, whatever, okay? The force of attraction, or the bond strength of H2 is a number. Is how many numbers?
413.
Is how many numbers?
One
It's one number. How much is it?
413 volts per mole.
It only gives you one number, does it give you like 3 or 4 different numbers?
Just one.
Just one number, because it is a force of attraction of this with this, let's say 430 kilojoules per mole. So on Earth, the force of attraction between this nuclei and this nuclei is 430 kilojoules per mole. How about in the moon? Is it 430? Huh?
I don't see
Of
why it wouldn't
course.
be.
Of course. Because it is the force of attraction between these two nuclei, it doesn't matter where it is. Is it 430 in the moon? Yes, it is. Is it 430 in the surface of the sun? Yes, it is. Now, where does it break easier? In the surface of the sun. Because the surface of the sun has more than this energy to break it, yes? But in the moon, it does not break as easy because there is no energy available, yes or no? Because energy of activation depends on breaking these bonds. Does the energy of activation change with temperature?
Yes. Well, it doesn't change, but it.
No.
Energy of activation does not change with temperature because energy of activation depends on the bonds being broken. And that does not change with temperature.
Okay.
Okay.
Yes or no? Some of you
Guy with the.
did not, why are you looking at the watch, man? You want to go home all right?
It's really early.
What happened?
No,
Yeah.
Yolanda always notices stuff like that. Okay? Yes or no, guys?
So energy of activation does not change with temperature.
Energy of activation does not change with temperature. Once you find out the energy of activation for a certain reaction, does it change?
no.
It does not change. The energy of activation for breaking this thing to form that thing does not change with temperature because energy of activation comes from breaking the bonds, yes? And that number is set in stone. Hello? Energy of activation is a number that does not change, yes? So, if the energy of activation for, let's say, oxidizing oxalic acid with potassium permanganate, it's just what you did today, yes? Oxalic acid with potassium permanganate, if it is 60 kilojoules, would it be 60 kilojoules in China?
Yeah.
How about in Germany? Would it be 60 in Germany?
Yep.
In the moon, 60. Okay? Everywhere 60, 60, 60. It does not change. And now, I am not finished telling you, because biologists will say, energy of activation changes when you add a catalyst, okay? Which is not true. But it is true, but it's not true. It's not true. Could be true. It's not, okay? So, if you are confused, don't you worry about it. But let's talk about this breaking ATP. When you break ATP, does it require energy or does it release energy to break ATP?
It releases energy.
It requires energy. 100% guaranteed requires energy. You know how much? 16 kilojoules per mole. That's how much energy is required to break the oxygen-phosphorus bond. Okay? Yes or no? So what is happening is, in order for you to break ATP, what do you need to do? you need to put this energy in it, yes?
Okay.
And once it breaks, the products are more stable than the reactants. So there is an overall, what? An overall release of energy. This makes this exothermic. So when you break ATP, there is a release of energy.
Yeah.
But breaking ATP requires energy,
Of course.
okay? Is that clear?
Mm-hmm.
So when you hear someone say, breaking ATP releases energy, that is not okay. Okay? Breaking ATP requires energy, but the products are more stable. So there is an overall release of energy, okay? Yes? Does your body need to give ATP 16 kilojoules before ATP gives back? Yes or no? Before your boyfriend gives you stuff back, do you need to give something to your boyfriend? All right, okay, that's the end of the day, guys, okay?